Jan Ozer here. I am today with David Ronca. A lot of us know David Ronca from his work at Netflix, where he helped pioneer per title encoding and brought VMAF to market. He later went to Meta, where he was instrumental in AV1 becoming a very popular format for Meta and Instagram distribution. Today, he's with RoncaTech. He's retired from those big companies. He's got his own development company, and he's going to talk to us about VCAT, which is the Video Codec Asset Test, a project he started at Meta and then took on his own with RoncaTech now. Thanks for joining me, David.
Thanks a lot, James. Good to be with you again.
So tell us, what is VCAT? Give us the 30-second flyby.
Yeah, so I think it's really an encapsulation. So in order to, there's been recent public announcements about the Meta's level of AV1 reach, which is roughly 75% of all global watch now is AV1, which is a significant milestone. In order to achieve that, there was a lot of work we did around understanding device capabilities. In fact, that was the foundation of getting AV1 so broad on Facebook. And so the work we did manually, the VCAT decoding benchmark tool is really like an encapsulation of that to make the next iteration of benchmarking for anybody much easier than the cruel manual testing that we had to do over the last few years at Meta. We do know that, with AV1, now VVC, possibly AV2, right, in order for modern codecs to get out in the market and start building, establishing value, we can't wait for hardware. We're seeing the hardware cycles now are very, very long, sometimes up to a decade. AV1 is beginning to get significant reach. It was public in 2018, so we're now, 7 years in, and VVC is not yet gaining traction. I'm talking specifically the mobile market is not really gaining traction at this point. It could or would presumably, if it follows the AV1 trajectory, would be somewhere around 2028. We'd start seeing, and who knows for AV2. The point is that in order to get these codecs out and to get them working and learning, we have to rely on software decoding, and software decoding has challenges, right? Particularly around device capabilities. So the VCAT decoding benchmarking tool really is, trying to help make that deployment of software decoding easier, although it fully supports hardware decoders. It allows us to establish a model for benchmarking. And what we learned at Meta was really the things we cared about were battery life and system overload, thermal events, thermal shutdowns, right? So when doing software decoding, you want to do long, and by the way, people watch video for sometimes hours at a time. And so the benchmarking should be hours at a time. It should be real life sort of content, right? The kind of content you'd expect, or the encodes that you would expect to get from a YouTube or a Netflix or one of the, Facebook, Instagram, TikTok, whatever. And then it should be a long running test so that you can see how that decoder is impacting the health of the device. Is the battery draining fast? Is the system overheating, overloading? Is it becoming unresponsive? So really, VCAT is kind of to allow you to have that insight into devices and the SoCs that are on the devices. And then, finally, as an academic tool, it really gives us a good model for benchmarking of software and hardware decoders, and really kind of understanding now, like we get a new decoder or a new codec. VVC is new, AV2 is now just coming out. Be really interesting to be able to run benchmarks on decoder implementations to kind of get a sense of how complex these codecs are, right? And in the past, that's always something that's happened really, really late. But now with VCAT, we can kind of plug in early and kind of get a look. And we also, in the terms of software decoder optimizations, right? If you look historically, hey, we made this work, and now instead of decoding 120 frames a second, we can do 180. Well, that's interesting, but how does that impact the user, right? Does that mean the battery's going to drain slower? It might, but if you're burning all 8 cores, right, to get 180, maybe you're going to drain faster, right? If you're having to run on large cores versus small cores. Anyway, so there's a lot of things there, and VCAT allows users to understand at a high level how these codecs will perform on a given device. without having to understand all that mess under the covers.
Okay, so I mean, if I'm a streaming service and I'm thinking about adding AV1 for software decoding on mobile, I need to do a bunch of testing. Most Apple devices have hardware AV1 decode. They have since, I guess, the iPhone 15, and they're very powerful devices. They aren't a huge problem. It's really the $100 or $200 Android device. What do I need to know about the device itself, irrespective of VCAT? What do I need to know about that device to know the gradations of the AV1 it's going to play?
Yeah, I mean, back up. I want to hit on that first point you made. If you have like a US centric product and you want to deploy AV1 software decoding, you're really not going to have a lot to worry about, right? The market is like full of iPhones, newer iPhones, and the Android devices tend to be very high-end Android devices for the most part. There is a segment of devices in the US market that are lower powered, but it's relatively small. So you could get really good AV1 reach just by like saying, if I'm one of these set of devices, right? iPhone's newer than X, Android of these various models. When you get out global, that doesn't hold up anymore because the global market is dominated by Androids, and it's dominated by Androids that are not $800 or $1,000 phones. They're $100, sub $100 phones, $100 phones, $150, $200 phones. And so that's where I think VCAT and really comes in handy, because you want to deploy to these devices, if you understand, which is it should be relatively straightforward. If you're delivering to devices, you can build a database and say, okay, here's like all the devices we're delivering on. Here's the top 90%, which would generally be globally. Your top 90% of Android devices would probably be between 250 and 300 different devices. And you'd probably say the last 5%, that long tail, we won't worry about. You could then look at those devices and tailor your experience based on those devices. And again, VCAT helps you understand capabilities. The fundamental principle of delivering AV1 at a high level on Facebook was bringing in what we call level aware playback. Now, we all know levels. Anybody who understands hardware decoding knows that hardware decoders announce a level. I can support level 3.1, which roughly means 720p video at 30 FPS. It's not exact mapping, but roughly you can generally think of it that, or 4.0 is 1080p at 30, 4.1, 1080p at 60. Hardware announces that, and all video players, streaming services, when they're dealing with hardware, they respect those levels, right? With software, it doesn't make any level declarations. And so it's one of the fundamental problems with software decoding is, just because a device has a 1080 screen doesn't mean it can decode software decode 1080p, AV1, or VVC. And that gets into the need for benchmarking. And if you can understand the devices, which is the work we did at Meta, if you can put level, restrictions on classes of devices so that regardless of screen size, this device only gets 720p at 30 FPS, right? Then you can know that you're going to have a good experience because you were able to benchmark and see what the battery drain. You can see that you're not going to be overheating the device and that sort of thing. So this is where VCAT, I think, would come in handy for a company that was looking to deploy AV1 software. That would be, it's not all software, but I would say globally, maybe you'd be lucky if 10% of the devices globally have hardware AV1 decoding. So this is where VCAT would come in. You could run these benchmarks. You could either run them yourself or you could run them through a third party who has a test lab, and you could get that information to make your decisions.
And who besides streaming publishers might be interested in VCAT?
I feel like it was always my hope that the network operators, right? Because network operators bundle devices. And if I'm looking at, I don't really know this world, but let's do a hypothetical. I'm a network operator and I'm currently evaluating the low cost bundled phones for 2028. Let's just say 2020. Let's assume I'm 2 years out, or 2027, whatever. I've got these devices from different vendors, Moto, Xiaomi, whatever, all the different vendors. And they're all at the same price point because everybody's going to know my price point. They're going to give me a phone. Now, the question is, which is the better phone? And I feel like this is also a hole in the world that really there was no objective way to answer that. Well, best for what, right? Some are the best looking, some are, a little cheaper, some have a little more memory or whatever. But ultimately, since video dominates, right, almost all user experience these days, to me the best is which one is the best at delivering like quality video or decoding or delivering a video experience. And then that could definitely vary by the device, right? You may have two devices at the same price point. I've talked a lot about the Moto E13, E14. These actually have a relatively decent SoC, right? It's an A55 class. It's a newer, it's not high performant, but it does solid and it can handle AV1 solidly. And I've seen new devices at the same price point with the previous generation of ARM A53s at the same price, and they don't really do as well, right? And so I think a network operator could use VCAT, run benchmarks on the phones they're looking at, and they could simply tell them, hey, they could tell, one vendor A, hey, we ran all these across all these vendors. Here's the results, right? Or here's how your phone did versus we won't tell you brands, but we'll tell you here are the other ones. And then so if the network operators were doing this and qualifying phones based on like performance, video decode performance. By the way, I always say software, but hardware matters for hardware too, right? And then wouldn't the handset vendors would probably want to start using VCAT, right? And so the handset vendors, because they're going to want to make sure their $90 or $150, $200 offering that they present to these network operators is competitive in the market. So maybe they would start using them. And then if they were using them, the SoC vendors are pitching to the handset vendors, hey, here's my SoC for your $100 phone. They've got like, a MediaTek, a Qualcomm, whatever, Unisoc. Then they can go run benchmarks and see which one of these, right, meets that price point with the better performance. So that's kind of the world I envisioned, right, all along. Whether or not it ever plays out, I don't know. But that was kind of, what I was hoping for. And that's the reason why my passion for VCAT extended past my employment at Meta. Meta kicked the project off. We had some architectural challenges. We made some significant changes, as I have mentioned before, which caused a extension of the release. And somewhere along the way, the decision was made, hey, David, it's really hard for a large company to support an open source project. And I think, somewhere along the way, hey, this doesn't really feel like something we want to like own. So they handed it to me. I finished the work because I'm passionate about it, because I really think it matters in the ecosystem. And, and I'm happy to have it out there and hoping people are going to be using it and finding value.
So we first spoke about it, I guess, last Mile High. So that's January 2025. I looked at it for streaming media in, I want to say June, July of last year.
Yeah, last summer I gave you a sneak peek.
Well, what's happened to the program? What do you have in your presentation for us to kind of mull over?
Okay.
In terms
well, since your previous video, we actually did release VCAT. It's now publicly available. Source code, everything is out. Licensing is straightforward. I had to work through that, and it's really just, it's released under GPL. So as far as source code, it follows GPL. And just on the liability side, basically, to use it, you agree that your only option if it's having issues is to not use it, right? There's no guarantees, no warranties. And we got that all out, and it's now a tool for people to use, and we're happy, if people can use it. So that was the first big thing, getting it out, getting it public. My intention was to have it on the Play Store, but because we use like the actual file system and not the app isolated file system, it doesn't meet the security requirements, and I haven't decided if I want to try. It's easier like sharing test vectors, which we're going to talk about, and things. It's easier doing all these things, grabbing log files, if you're not using a private file system. And so then I have to decide, is it really an issue that is not in the App Store? Because, let's face it, right? VCAT is not the kind of app that like, a billion people are going to download and use, right? There's a very small population. It's, so I have an APK that you can download and install. And for people who have a concern about that, even though the Android does a scan of it and declares a state, because we don't send anything out. There's no network act. We don't collect any data. It doesn't do anything. Actually, we do collect data. It's all stored in a CSV file, and it's only performance data. There's nothing sent to RoncaTech. We don't know who's using it. I don't know if there's 1 million users of VCAT right now or 2, right? I have no idea. And it's not something we really care about. So we have it out, and it's useful, and we got it out. That was a big deal. Again, people who don't want to install the APK can pull the source and compile it and run it themselves. And now we have done an update, this is what I was excited about now, is what I call beta 4, and I'm still calling VCAT beta. It'll probably be beta forever. So beta 3 was the first public release. Beta 4 public is now what we want to talk about today, and I got a few exciting updates to discuss. There's just a few new features in beta 4. First of all, we have improved test vector management. Test vector is the ability to save off test sets and then share those and install them locally on your device, so you don't have to build everything by hand. I think what's most exciting for me is VVdeC is integrated, so now we can begin running VVC software decoding benchmarks and have some VVC versus David benchmarking results to talk about.
So that's the Fraunhofer decoder, VVdeC.
Yes, VVdeC is the Fraunhofer decoder. I have a few caveats on those results. We'll talk about that when we get there. So first of all, let's talk about test vector management. So the test vector, the idea behind test vectors is like, if I'm a company and I have, let's go back to the network operator scenario. Imagine the network operator, right? There's a handful of streaming companies that dominate their traffic, right? It's YouTube, TikTok, Netflix, and Meta, right? Imagine if each of these companies said, hey, here's a set of benchmarking vectors for if you want to see how Netflix is going to perform on your device, if you want to see how YouTube, how Instagram or Facebook or TikTok, which are all very different.
When you say vector, that means something to you. It's kind of general for me. That means CPU cycles. Does it mean screen?
No. So to me, a test vector is a set of one or more video assets and a playlist, and that's what you run, right? So effectively, a single vector would be a playlist and whatever one or more video assets that are included in that playlist.
What about because you're configuring that specifically for the test? You're doing screen brightness. You're doing how many threads can be used?
Yeah, so those are test conditions.
Okay.
And so it's different. So imagine let's go to I'll just pick TikTok, since I really have no engagement with them, and everything I say about TikTok is purely hypothetical because I really have no idea. But let's just say TikTok has a set of VCAT vectors for, network operators to use, which may be VVC or HEVC, right? So they would have a set of videos that they feel are a good representative set for the TikTok experience. They would probably have playlists that use one or more videos. And then when they share a test vector set, it would be a set of videos and playlists that you can install onto a device, and then they're readily available in the playlist panel to pick and run, right? And I'll show that when we get to, I'm going to do a quick demo. So that's really what a test vector set is, right? And so, Netflix would do the same thing. Maybe they have here's our SDR test set, here's our HDR test set. And that includes videos and playlists, and they could have that all as a zip file, and you could unzip it locally, and then you could import those into VCAT. It would set up the playlist, and then you could just click and run. So that way it would allow 5 different companies to all run a benchmark, a TikTok benchmark, or a Netflix benchmark, or a Facebook or Instagram, whatever, because you could create these test sets and share them publicly or privately, however you want to do. So the test vector panel on VCAT has an import and export, and one thing that hasn't changed is if you hit export, it just says under construction. So you still can't, in beta 3, there really was no way for anybody but me to create test vectors. With beta 4, we've changed that. because even though the panel is still disabled, you can generate test vectors on your local system. There's a new tool called VCAT Test Vector Builder, and you can set up a folder with some media assets, and if you run these Python scripts, it will build the. So what you have, what a test vector is, you have it's really video and playlist when it's installed on VCAT. But as far as a shareable set, you have video assets, and every video asset has a manifest that includes a checksum, right, for validation that hasn't been corrupted. And then you have playlists that reference the video, but they're not VCAT playlists. They're this test set playlist. They reference a video asset. And then you have a catalog, which a catalog would be like AV1 or VP9 or VVC, horizontal, vertical. And then you have your library, which is a set of catalogs. So you could have, like, that's what I showed in the previous screen, catalogs here, right? So VCAT AV1 demo, that's a catalog. Vertical is a catalog. So the vector builder allows you to set these up, and basically you end up with a folder structure that you could either just push over to the device, you could zip it up, you could put it on Google Drive. There's, if you can get that folder structure to the device, then from VCAT you can browse that folder structure and it'll then populate. So you'll end up getting the panel of your test assets will populate just like this. You could pick the ones you want to import, and you hit the button down here, and that would bring those in, set up playlists, copy the media assets. So that's kind of the concept, how this works. Does that make sense?
Okay. Yep.
Cool. Moving on, so the next thing, which I'm really excited about, is VVdeC support. So VVdeC is the Fraunhofer public, I'll say optimized, I'll put quotes around optimized VVC software decoder. So we've integrated that. It's open source. It's integrated. Benchmarking works, and that is in beta 4. And so here it is. I've got video running. You can see in the information, the overlay, you can see that we've got VVdeC 3.0. You can see in the configuration screen, the test conditions configuration for VVC. We want to use VVdeC. So this is the next one. And then finally, this is all up. So what? So with that, I ran another benchmark. This is on an Oppo CPH 2625 with a 1080p, 30 FPS, 3 threads, because I can only get 3 threads to work on VVdeC, and 25% screen brightness. And this is the kind of interesting data that I believe VCAT gives you. So from the data generated, the telemetry data, it's a CSV file. We can simply bring that into a spreadsheet, any spreadsheet, and plot it. So this is David 1.5 versus VVdeC 3.0. And you can see that on this device, David is giving you about 21 hours of playtime before that battery gets down to 15%-ish. And you can see that VVdeC is actually about a third of that. It's actually draining off pretty quickly. Also, there have been occasionally thermal events. So because we do log thermal events as well, and occasionally we were not seeing consistent overheating, but occasionally we would get a flag that, so our status would be, green, orange, red. And occasionally we would see the red light mean there was at least one period where thermal went from beyond, I think it's a 1 through 5, and anything 2 or less is orange, 0 is green, 2 or less is orange, anything above 2, which would be 3, 4, 5, is red. So it basically the device is starting to warm up. We didn't have a thermal shutdown. We didn't have anything like that. But and of course you could plot the thermal events over time. I just didn't do that. So I want to the caveat here, because I thought these results like I'm doing something wrong. Like I must have a bad integration. But we verified the results using the VVdeC player, so got VCAT out of the way. And then when published it, one of the Fraunhofer engineers came in and said, well, VVdeC doesn't have anywhere near the level of optimization that David does. So we're not surprised at these results. So it makes me feel like we're pretty good about, we've actually got this captured. So I'm pretty content now. Of course, it's all open source, so I would love nothing more than somebody to come in and say, "Hey, David, you really screwed up this integration, and I just got this, I just cut this drain in half or something." I would love that, that somebody, is out checking my work.
It's got to be a pretty lightweight app, and it's not going, the player is going to determine the efficiency. Why? What's your guess as to why Fraunhofer didn't optimize? Was it because they want to charge for their optimized version? I mean,
No, I don't think so. Fraunhofer's not in the business of, as far as I know. I mean, they license IP, and they're not. I don't really think they're. And I'm not speaking for Fraunhofer, but as far as I know, I don't think they're really in the business of licensing solutions, paid licensing solutions. I could be wrong, but so VVdeC is not intended to be a commercial decoder. It's intended to be a use, because this is the difference between the AOM community and the ITU-MPEG community. ITU-MPEG codecs, when they release reference code, which is hideously slow encoder and hideously slow decoder, and that's their reference. And and productization is like left as a exercise for the reader. And so Fraunhofer kind of took that one step. Hey, we're making this decoder, but I don't think it's something they license. And the suggestion is that if you used a private decoder from one of the companies that's supporting VVC, like Tencent, I have no idea, Tencent, or maybe TikTok or somebody, you actually would see much better performance. That I can neither confirm or deny. I have no idea, and I'm not really set up to do private closed source codec integrations. I mean, I could, but it's not really my intention. But VCAT's open source, so any company could take VCAT, integrate their codec, and produce these results. Right? They should be able to generate these exact same results.
Show us the application to the extent you can on this computer, specifically the data you're getting out of the testing.
Certainly. So we'll switch to a demo. So yeah, so we got VCAT down here. I will launch it very quickly. So we talked about test vectors. So this is a playlist. And to me, this is a test vector. It has, it's a playlist. It has video assets, which you could see here, and you can play it. So this is actually our test vector panel. And you can see these are all the RoncaTech provided demo assets. And you can see our VVC set down here. So you could come in and you could say, well, I'm only interested in AV1 and VVC. I will select these. I'm not going to hit the download because it will take some time. It's pulling from S3, but you could do this and you can download whatever you want. And this is where, if you created your own test set, you could share those. And if people use the browser, the folder browser here, go out, find that folder on the device, it would then populate this panel with those test set, right? That test set. And you could select what you want and import it. So I'm just going to select one very small video file here and just import it just to show how it works. So it's going to download the video, validate the checksum, then it's going to pull down the playlist, validate the checksum, and then it's going to take the vector playlist and turn that into, and you can see we already have that. But so this is how you get, so when you install VCAT, there'll be nothing there. And if you go to this panel, it's going to, and you have internet connectivity, it's going to populate with the RoncaTech test set. You could check everything, hit download, give it a couple minutes, and it would populate you with playlists. So I'm going to come over here to run test conditions and just quickly show, here's our VVC, so you can set this up. And then I'm going to come here and I will go down. I'm just going to pick a VVC and run it. And I'll hit the information button, and you can see that we have the VVdeC is running. So we're actually decoding VVC at this point. And that is VCAT Beta 4.
What's the show us a data file that you can get? Can you get
Oh,
access more?
well, first of all, I'll come here to the results. I just ran a test. I'm not sure which of these, but if you click one of these, you can see, well, we ran a 6-second test. The battery, of course, didn't move. If you have a longer test, this is just a summary. So it's telling you what you were decoding, and you see it was frame rate. Everything is green. Obviously, there's some UI problems there. So everything is green on this one. If we had temperature, which occasionally this would go orange or red. And so this is the summary data. Would you like to see the actual CSV data?
Yeah, do you have the ability to call that up real quickly?
I do. So let's get rid of this. Cool. So this is actually the telemetry file from a VCAT session. This was actually we'll go through it. So we start out at the top. Before we get into our CSV data, we have a JSON blob, and this is how we populate the UI within VCAT. It tells us the device, tells us the version, tells us the device we're running on, tells us the core types, the resolution, how much memory, storage, and then we get into the session. So it tells us the starting battery. This is the test we're running, and then the start time. This is the VCAT version, and these are our test conditions. So you see the decoders we're using. We have the run limit. We're going to run till 15% battery, screen brightness, and threads. And then the video rotation is set to match a video. So if it's horizontal, it'll lock horizontal, video, vertical, lock vertical. Then we actually get into our telemetry data. And you can see this actually quite a bit of data here. Here's the battery level right here. And you can see this is actually VVC. You can see over time how that is winding down, right? So you can see that part. If we get over here, we have our the CPU information we can collect from in-app. You can't collect everything, but we can get CPU frequencies. We come across more battery data. We have the test duration, the actual file we're running. I think we have more details in here. And then there's a few fields that aren't working, obviously. We have the resolution, we have the codec, we have the frame rate, and what the memory that's being used. There was the thermal events are in here somewhere. Oh, right here, system thermal. So you can see system thermal, battery thermal. So yeah, so this is the telemetry data. You can see it's a large amount of data, and it's pretty complete. But the system's flexible, so we can always add fields if there's missing things. So
okay, that's updated every how quickly? Second?
So have it set up now that then the log writing might begin to impede or become a factor. So we have it set up starting every 30 seconds, and you can actually see and then it'll roll off. It does an exponential roll off. So the longer you run, the longer the cycles are up to a point. So you can see if you actually, I don't have it, but if you do the delta from one event to the other, you see we're 30 seconds here, right? 30, 30, 30, 30. We gradually, then we get to 40, 40, 40, 40. Then some point, I think we max out at like a minute or two. Just because if you're running 24 hours, right, you logging this continuously could be an issue.
It's a lot of data anyway you look at it.
Yeah, isn't that the Heisenberg, right? We don't want to start draining battery by doing so many file writes, and we don't want to bleed the thing out of disk storage, or whatever. So I have to be a little mindful there.
So you've been careful to call this VCAT decoder. Does that imply that there's going to be sister products that maybe do something different?
Yeah, so that I think that well, I don't really want to get into specifics yet. We already kind of have vision for additional VCAT use cases. One would be encoder, right? Wouldn't it be? Now, encoding is not a battery drain test. Encoding, and you often hear me, whether speaking or writing, I use the cost-benefit codec comparison model that Yannis Katsavanidis developed at Meta, because I believe that's the only really useful metric when you're comparing two codecs. And not that and remember, as you pointed out in one of your posts, we're not comparing codecs, we're comparing implementations. But when you're looking at implementations, it's not just, oh, this codec says 30% more than this or 15. It's a question of what does that cost? And it costs on the encode and it costs on decode. So wouldn't it be great if we were able to run hardware and software encodes across all the codecs on Android, given Android devices, and generate that cost benefit by consuming this many watts, you get this much efficiency, right? How does X264 compare to like the hardware HEVC, right? I would beg to, or I would argue, at least hypothetically, I would bet that a modest speed setting of X264 would outperform most mobile hardware HEVC encoders. But the battery is going to be an issue, maybe. And then you have to say, well, I'm only encoding like, 20-second videos, and I only do like one or two. It's not like watching where I sit there and encode. So I feel like VCAT encoder would be very, very useful. And then obviously, think about GPU heavy scenarios, right? Makes me feel like some kind of VCAT GPU benchmarking tool would be very useful. These aren't necessarily battery drain tests. GPU might be, but I think GPU would probably be more interested. Encoding, you're interested in, within a reasonable battery drain rate, what's the best quality video I can generate. For GPU, it's probably for a given device, if I'm like a gaming vendor or something, what's a reasonable level of compositing I can do, or 3D rendering or whatever on these devices. So it's a little different. It's not necessarily battery drain, although it could be a combination. And then of course we get into the AI space, right? What is certain AI operations, how do they work? And by the way, back to VCAT decoding, I know there's been a lot of excitement around AI codecs. I'd love to plug an AI decoder into VCAT and run a battery drain test, because we can get excited that, hey, this decoder or this codec, this AI codec, is 30% fewer bits. But if you're on an iPhone on 17 and AV1 software drains it, you get like 28 hours, and the AI you get like 3 hours. And maybe you say, well, it's a very interesting academic exercise, but it doesn't really have a lot of value, in the practical world. But on the other hand, if you had an AI codec that was leveraging like the iPhone NPU, and it's like, hey, look, we got, 24 hours, right, versus 28 software or 20, whatever, and look how good it is. It'd be like, whoa, okay, this is like a real deal. So even getting back to VCAT AI for AI operations, not including encoding or decoding, would be useful. And VCAT decoding, I think, would be very useful for benchmarking modern AI-based codecs.
Well, the funny thing about what you said, or actually what you didn't say, is we always could test 21-hour decoding cycles. The problem was you had to be there for 21 hours, or at least the last few hours. And what VCAT does is it gets you free of that, particularly in the context of playlists, where you can actually do multiple tests. You don't have to be there to set it up. So the work I've done, when I was doing some testing for a project, it was fabulous for me. And
yeah.
But I'm also giggling at the fact you're talking about VCAT AI, and VVC seems like it's 10 years off. So AI is just, my goodness, when is that going to be relevant to a $100 Android phone?
Well,
I wish it was next year, but I don't.
But I think that it's going to be relevant, right, when we have the ability to understand what we can and can't do practically. And so, let's just say I've got and again, I'm getting into areas where I can speculate, but I can't be authoritative because I have not invested my time into this emerging world of AI. But, right now, most of the video AI stuff is happening on the back end. It's happening on GPUs in data centers or at the edge. And, wouldn't you want to move as much of that as possible onto devices just to make more GPU? I mean, GPUs are expensive, right? So if, maybe I couldn't run my video background removal model reliably on my $100 phone, but what if like I could run it on so many iPhones and high level Androids? Then that traffic gets shifted off of my NVIDIA chips running in the data center and onto local devices, gets more responsive for users. I get immediate feedback. I don't have, so, maybe there are some limited AI operations you could do on a $100 phone. Maybe more than we think. But maybe also there's a lot of things you could do for more powerful phones that create a better experience. And who knows, maybe that drives upgrades, right? Why would somebody go, like somebody who can barely afford a $100 phone, spend 200? Well, if there was a use case that was compelling that maybe wanted them to stretch their payments out for another year, maybe they would, right? But if they watch a video on their E13 and it's like, this is good. This is good quality screen, a good experience. I look at my friends who's, paid 500 and his looks good, but it's a little better, but I'm happy. But, who knows? So maybe getting into the AI space in emerging AI applications and capabilities, maybe there's a scenario where AI could drive. But in order to do that, you need to start building understanding. So what I will say is like these new VCAT, like something like an AI VCAT is at the bleeding edge where decoding, is really at the tail. Right? Well, still useful. Decoding is still useful, but decoding, you're using established decoders, decoding videos and really collecting data. There's really nothing mysterious about that. But I'm you built an app that does background removal, right, or changes my clothes or something. What does that look like running on a device? I don't know. So
you built VCAT because you wish you had it 5 years ago. So it's nice to have it now for prospective applications as well.
Well, what I will say, because you mentioned the time. So if you go back to my Mile High video, all my benchmarking were 16 hours. Why 16 hours? Because that's what I could do. Getting up first thing in the morning, I'd have the phones charging all night, get up first thing in the morning and get them running. I mean, this was when I was still, working, and I would drive to work with 2 or 3 phones on my passenger seat. I have my little, I figured out how to have them not, fly around. I'm on the dashboard. My wife and I would go somewhere and have it running, and I got to run out the car real quick. Run out, and I'd capture data. I kept thinking I should build like a logging app that just collects data, but we were just focusing on the benchmarking, and so and then I managed to. Sometimes it took a couple tries because I'd forget or something, but I was able to collect data. This is very difficult, and yes, so VCAT decoder is an encapsulation of all the pain I suffered for the last few years and everything we've learned. Because Meta recently publicly announced that 75% of global watch, and this is primarily Instagram and Facebook app, is AV1, not 75% of encoded videos, 75% of the videos being watched by people. This is a huge, huge number. And I'm not going to get into the, 3.5 billion users. You can kind of do the math, right? Among the largest video deliverers of video across mobile networks in the world. And we've been working on that for 5 years. We've been benchmarking for 5 years, 6 years. Started in early 2020, just getting into COVID. We actually had an engagement with Idiom. Idiom set up a lab for us. They populated it with I think it was like 300 devices, which generally speaking, globally, you'd have about 300 or 400 devices would represent like probably 90% of your user population, Android population. And they started running benchmarks, and so we've been working on this problem for years. VCAT is kind of like everything that's been really difficult, right, made easy, right? All that learning. So anybody else who wants to run benchmarks, whether they're going to run it themselves or they're going to use a third party like Idiom or somebody else, the VCAT's going to make it much easier for them, and it should make it cheaper too, right? Because now they don't have to like build custom benchmarking and everything else.
So David, thanks for the presentation and thanks for the demo. Where can people get VCAT?
Yeah, great question. So I do have a post on LinkedIn, and that post has a link to the APK that you can directly install on your Android device. It also has a link to the to the project, the GitHub project, so you can pull the source and build it yourself. It also has a link to the test vector tool set, so you can bring that Python code down to generate test vectors. So it's all available. You go find my profile on LinkedIn, find that, and I will ping that to put it at the top of my post, just so after, actually I'll put a comment on your post, so anybody can then just follow right into that.
What about RoncaTech? Can I get there from the website?
That's a good question. I haven't been paying a lot of attention to that website since I bought it. You should be able to, though. You should be able to.
Okay,
I should
so
have a project page. Now I'm going to take that as an action item. I should have a project page, and if you clicked on VCAT decoding, it would bring you to the PDF that gives you the beta 4 PDF that gives you all the instructions you need. So at this point, no. If you go to RoncaTech today, you will not be able to get to VCAT. But
okay, so look you up on LinkedIn, find your post, and then people watching this video, I'll include links in the web page that the video's on. I'll include it in the YouTube video,
yeah.
and in the LinkedIn video as well. So
and by all means, I'm happy to have conversations with anybody that thinks they have a VCAT or benchmarking use case.
okay,
We don't, I make stuff simple. If we stay away from, I don't have anything under NDA. If the company doesn't share anything, then we can just have a talk. We don't have to have any paperwork. We can just have a 30-minute chat. So I make myself very accessible, for companies that are just curious.
okay. Well, listen, thanks for taking the time. It's always a pleasure to catch up, and we'll be talking soon.
Thanks a lot, Jan. It's good talking to you.